Hello, ladies and gentlemen, and welcome back to more of the 2006 Fermat paper. We're on question number 22. So hopefully you've tried this one, download a copy, etc. You know, the usual things I try and get you to do, because it's the best way to practice. Anyway, Quincy and Celine have to move 16 small boxes and 10 large boxes. The chart indicates the time that each person takes to move each type of box. Okay, so let's stop for a moment and look at this chart. If I'm reading it correctly, it takes Celine 2 minutes to move a small box. It takes Quincy 3 minutes to move a small box. Celine takes 6 minutes to do a large box. Quincy takes 5 minutes to do a large box. Okay. So they start moving the boxes at 9 a.m. The earliest time at which they can be finished moving all the boxes is... And we have a bunch of different times, each of them within 1 minute of each other. So we're going to have to be pretty sure. Now, sort of the best way to rule out certain possibilities is to, so for example, if I know that they can finish by 9:43, you know, if there is some way for them to finish by 9:43, not necessarily that that's the best way, but if I can show that, you know, if, you know, Celine moves 8 of these boxes and Quincy moves 5 of these boxes or whatever, and they finish at 9:43, I automatically know that D and E are out. So if I'm trying to focus myself on something, I might try and focus on showing that you can do they can finish in 9:43. That would narrow down my options. And then, you know, maybe I'd try for 9:42 or 9:41, things like that. Okay, just trying to think about this and exploit the fact that it's a multiple choice contest. So they got to divvy up the labor. Now I noticed that Celine is faster with small boxes, Quincy is faster with large boxes. So I'm going to guess that a good solution, the sort of the time at which they can be done earliest, will probably have Quincy moving more of the large boxes and Celine moving more of the small boxes. But we kind of want the totals of how long, we can calculate how long it takes Celine to move all of the boxes assigned to her, and then calculate how long it takes Quincy to move all the boxes assigned to him, and we want to sort of get those numbers to be as close as possible, I think. Okay, so let's go to our notepad, and so it's Quincy and Celine, so I'm going to let Q equal, actually, I was going to let Q be the number of boxes Quincy takes, but they're small and large, so let S equal the number of small that Quincy moves. And we'll use the curly L so it's not confusing with the regular L, which kind of looks like a 1, for the number of large boxes that Quincy moves. Okay, we can set it up the same way with naming the number of small boxes that Celine moves or whatever, and you can actually mix and match if you want. I don't know, gender equality or something. You know, give Quincy the small boxes, L be the number of large boxes Celine moves. The point is we can get the other person's movements, the number of boxes they move, pretty quickly. So this is the number of small Celine moves. And it was 10 large, right? Yeah, 10 large boxes in total. Quincy takes L of them. And maybe L is nothing. Maybe L is 10. Who knows? Then 10 minus L is the number left over that Celine has to move. Okay. So, in terms of, and since I've now given names to everything that they can do, I can actually spit out time. So Quincy's time is going to be it's 3s plus 5l, right? Let's just double check that. Yeah, 3s plus 5l. And Celine's time will be 2s plus, oh no, not 2s, 2 times 16 minus s. plus 6 times 10 minus L. Alright. So I can at least clean up Celine's time. 32 minus 2s plus 60 minus 6L. That's 92 minus 2s minus 6L. Now I want not the total time reduced, but if I just wanted total time, I could add these up, and I'd get 92 plus s minus L. But I don't actually care about the total amount of time. What I want is the maximum number, the maximum time between these two to be as small as possible. That's what we're looking for. And I don't know the best way to talk about maximum time right here. I suppose we could probably make a chart given some S's and L's and calculate Quincy's time and Celine's time and figure out whose is the maximum there. But I'm trying to avoid a chart at this point. I feel like there's an extra step I should be doing, and then we can throw a chart at the situation. Well, I suppose in some way we can relate maximum time, the maximum time between the two of them, to the total time. We can rule out certain maximum times, I think. Let me just explain what I'm thinking of here. So if I have the max time, then 2m has got to be greater than or equal to the total time. And I can figure out the total time. So, now the total time is going to be in terms of S and L. So what I wanted to do was say, oh, get this nice relationship, and then we can say something to the effect of, could the answer be 41? Could it take them 41 minutes? Because that would be how long it takes from 9 a.m. to 9:41. Could m be 41? And then we'd say, well, no, that's got to be 82, and that's greater than or equal to the total time. But that's not greater than or equal to the total time. And maybe that'll work because we got this 92 here. The problem is we're going to get 92 plus s minus L, and I think that's going to mess things up. I don't know. Let's find out. Technically, if we want to be super awesome best mathematicians, we should point out that m depends on our choice of s and L. And so does the time. And when I say max time, by the way, I mean the maximum between Quincy's time and Celine's time. But my point still stands. Twice the maximum time has got to be greater than or equal to total time, which in terms of S and L is 92, 3s minus 2s is plus s, and 5l minus 6l is minus l. Okay. So now s minus l, the smallest this can be, if s is 0 and l is 10, I do get 82. So 41 is still a possibility, I guess. So have I really gained any insight? Well, if this were 41, we'd have to have 2 times 41 is greater than or equal to 92 plus L minus, plus S minus L. So 82, and then I could subtract off. So I could rearrange and have L minus S is greater than or equal to 92 minus 82, which is 10. But of course, this itself is greater than or equal, or is less than or equal to 10. So L would have to be 10, S would have to be 0. And then, knowing that that has to be true, I plug in and ask, is that actually the maximum time? So I think now we can at least start maybe a chart. So I'll have L minus S has to be bigger than or equal to 92 minus, I'll also have M for max time. So we could have 41, 42, 43, and we're just going to work down the chart, exploiting the fact that it's a multiple choice answer. Okay, we'll try 41. If we can't get 41, we'll try 42. Okay, this is sounding a little better. So 92 minus 2m, I suppose I should rearrange this a bit as well. That's the max time, and then that has to be less than or equal to L minus S, and then we're going to get possibilities for S and L. And then we can get Q's time, C's time, and then the actual max of Q's time and C's time. Is that actually going to be 41? Okay. So here we go. So this would be 92 minus 82, which is 10. So this has to be 10 because this is less than or equal to 10 already. So it's squeezed. It has to be 10. So this has got to be 0 and 10. And Quincy's time is 3s plus 5l, and this is 92. Well, this is really just 92 minus plus l minus 92 minus 2s. I was trying to relate it to Quincy's time. No, it's minus 2s plus minus 2s minus 6l. Alright, so that would be 50. Already, that's going to be a no-go because our max would be at least 50. So I don't even need to work out Celine's time, but then this might work out for the best. Okay. Suppose it takes them at most 42 minutes. Then that's a difference of 8. It'll be 6, 4, and 2 here. But this means L minus S could be 10, but I already know that's not going to work. L minus S could be 8 or 9. There are certainly these possibilities here. So we'd have... I'm going to need more space for my different possibilities, aren't I? And actually, we don't need to check 45. We can rule out everything up to 44. We're all set. Okay, so we could have 2 and 10. That would give us 8. We could have 1 and 9. That would give us 8. We could have 0 and 8. And that would give us 8. Or we could have 1 and 10 or 0 and 9. So lots of different options here to get 42. And I'm starting to think there'll be even more options for 43, so maybe this wasn't the best way to do it. But I've got a method that's going to work, so we're going to sit there and look at it. Now, anytime I see 10 over here for the L, I know that this is going to be greater than or equal to 50, because we're at least going to have 50 here, and that's not going to work. We're looking for 42. So I can actually rule out this one and rule out this one automatically. Now, how about 9? Well, we'd have 5 times 9, which is 45. So this is greater than or equal to 45. These ones aren't going to work out. Okay, it's actually working a little faster than I thought. How about 8? We'd have 5 times 8, which is 40. That's less than 42, so we actually have to compute Celine's time here. So that'd be 92. So with the 0 and 8, that would be 92 minus nothing minus 48. 92 minus 48. For some reason, I'm not being able to do that in my head. It's going to be 44. So that's a max of 44, but that's still not good enough. Okay. Now, with in order to get 6, well, we could have 7, or we could have 6, and we could have 7. We don't need to check, like, 8 is still a possibility, but we know each of these 8s gives us something that's at least bigger than 43. It's at least 44. So 44 is looking like a possibility. It might be D44. If I had to take a guess at this point, I'd guess between 43 and 44. And that's narrowing it down to 2, and that's not bad. But I don't need to check when L minus S is 8. I've already covered all those possibilities, and our max is at least 44. So we just need to check 43. If we can get 43 to work, 43 is the answer. If it doesn't work, we don't have to do anything with 44. We know that 0 and 8 will already give us a max of 44, a total time that they take together of 44. All right, so how can we get 6? Well, anything involving 10, like I can list 410, but it doesn't matter. This is going to be greater than 50, so don't worry about that. Same with the 9. So let's start with the 8s. I could have 2, 8. I could have 1, 7. I could have 0, 6. Or I could have, I guess we don't need this anymore. Or what else could I have? For 7, I could have 2, 9. I don't need the 9s. I could have 1, 8 or 0, 7. All right, so 1 and 8, that's 43. Just picking this one because I saw it. 0 and 6, that's, and that 43 would be fine. 0 and 6, that's going to be 30. That's going to be way too small, I think. 0 and 7, that's going to be 35. Again, I think it's too small. 38, and then 2 and 8, that's going to be 46. That one's way too big. Let's focus on this 43 one here, because we're doing so well. 92 minus 2, so that's 90, minus 48, that's going to be 42. And look at that, we've got a max of 43. And we know 42 won't work, 41 will work, so... Or sorry, not the total time, but the max time between Quincy and Celine is 43 minutes. So it would take them until 9:43, and I think that was answer C. Alright. So this may not have been the cleanest way, but I did use some math to narrow down my options. It wasn't just a giant guess and check. And I like that it's fairly fair between the two of them. It took Quincy 1 extra minute past Celine. That's a nice and fair division, I would think. Not a whole lot else to say. As we worked up from the bottom, because if 41 happened to be the answer, we wouldn't have to check anything, whereas if we'd checked 44 right off the bat, we would know there is a way to do 44, but maybe we can do better, and indeed we can. And on our way up, we saw that 44 would work, so that ruled out both E and made D a very likely candidate for an answer, and so we finally settled on C. Okay, and that's question number 22. So we've got 3 more questions to go. I will see you guys in the next video for question number 23 on the 2006 Fermat paper. So thanks for watching. Have yourselves a wonderful day.